Hello everyone, as you know, my name is Daniel Fernandez. I am the owner of scienceinhydroponics.com, and today we are going to be talking about large-scale preparations of hydroponic stock solutions, so concentrated nutrient solutions. Up until now, I have shown you how to do small-scale preparations, where we've used a very accurate volumetric material to prepare nutrient solutions, but I guess you might have guessed that we don't have like 1,000-gallon containers like this. So why is that, and why is it different to prepare large-scale formulations? So the main issue we have is that to have accurate concentrated solutions, we need to know both the mass of the things we're adding and the final volume of the nutrient solution. Measuring large masses is no problem. We have really accurate scales even for very large masses, so that's not a problem. You can measure 40.15 kilograms with pretty easy to get scales, but measuring accurate volumes in a large scale is really hard. For example, how do you measure 100 gallons of a final volume of a solution? This is very hard because containers that you can buy that have 100-gallon marks in them, those are not very accurate. They actually have even plus or minus 20% deviations. So if we want to actually prepare large-scale solutions with accuracies in the 2 to 5% region, we just cannot use those levels in containers to measure volumes. What we can measure accurately is the amount of water that we will be adding to the solutions, because we have flow meters that have accuracies in the order of 0.5 to 1%. So we can actually measure the volume of water. However, the volume of water is not the final volume of solution. If you need to prepare 100 gallons of concentrated nutrient solution, this does not mean that you need to add 100 gallons of water, because the salts that we will be using take up volume. So you will need to add less than 100 gallons. So it is not just take a flow meter and add 100 gallons of water, because then the volume will be greater than 100 and the concentration will not be the concentration you intended, because the concentration units we're interested in hydroponics all depend on the final volume, because we are interested in then doing dilutions volume to volume. So we need the final volume of the solution to be accurate, for the concentration to be known, for volume to volume dilutions to be accurate. So how do we actually find out the amount of water that we need to add so that we can measure the volume of water instead of the final volume of the solution? Well, this is what we are going to learn today. We are going to use this using calcium nitrate, and then I'm going to show you in a small scale preparation how we can actually come up with this and then scale this up to a slightly larger preparation, but that does not use this. For this example, we are going to be preparing a calcium nitrate solution that, when you start 10 milliliters per liter, gives you 100 ppms of nitrogen as nitrate. So the first thing I'm going to do is to weigh the amount of calcium nitrate necessary to prepare this solution for a final volume of 250 milliliters, which is going to be around 17 grams, 17.3 grams. This initial weight I'm going to call W1, which was 17.48 grams. Now the next thing I'm going to do is weigh the volumetric flask with the stopper. It is very important for the volumetric flask to be dry. So this has been pre-purged and then dried. And I'm going to call this W0, which is the weight of the empty flask with the stopper. Now I am going to add some water and just dissolve the calcium nitrate in a beaker, and then transfer these to the volumetric flask that I have previously weighed. Being careful to wash everything to get everything transferred properly. Now I'm gonna take the volumetric flask to volume, as I've shown you several times in previous videos. Now I'm homogenizing. And then the final thing I'm going to weigh, I'm wiping the volumetric flask very carefully because I'm going to weigh it. So I'm going to weigh the full volumetric flask with stopper with all the solution in. And this is what I'm gonna call W2, which was 376.77 grams. Now what we're gonna do now is that we're gonna calculate how much water we had to add. In this case, I just subtract from W2, W1, and W0, which gives us an amount of water of 243.05 grams of water. Now what we're going to do is that we're gonna prepare a 300 milliliter solution. So I'm going to add the calcium nitrate first to prepare this 300 milliliter solution without any volumetric material. So I'm just adding the calcium nitrate now, which is 20.8 grams. And now, using the previous information we got from the small scale procedure with 250 milliliters, I can calculate the amount of water that I need to add. You can see now this is W5 and it is actually 97.2% of the final volume. In this case, this means I need to add 291.66 grams of water. In this case, I'm weighing the water because it's easier at this slightly larger scale. You can see that I'm not using any volumetric material, I'm just using a plastic container because I don't care about the volume of the container, I just care about the amount of water that I'm adding, because thanks to the previous process, I now know exactly how much water I need to add to achieve the final volume, considering the volume of the salt. Now it is just a matter of adding a magnetic stir and homogenizing the solution, making sure all the calcium nitrate dissolves. Okay, so now we have prepared two solutions that are exactly the same, but one was prepared using volumetric material and is 250 milliliters exactly, while the other one is 300 milliliters and it wasn't prepared using volumetric material, but it was actually prepared by weighing the solvent. So we knew how much to weigh because we knew exactly through the small scale preparation how much water we had added, but we decided to weigh it because it is just more practical for this like intermediate scale to weigh the water. The density of water is almost exactly 1, so in practice you can either weigh the solvent or measure the water in like small to intermediate scales. For example, if you're doing 1 gallon or even maybe 5 gallons, 10 gallons, it's often more practical to have a scale where you just weigh the water. But for large scales, let's say you're doing 50 gallons, 100 gallons, 200 gallons, you definitely don't want to weigh the water you add, but you want to use a flow meter, as I mentioned before, so that you can measure the volume of water we add. In this particular example, you saw that the amount of water we needed to add was actually 97.2% of the final volume that we wanted to achieve, which means that the calcium nitrate takes up around 3% of the volume, which is what we expected. As I mentioned in the beginning, we expect that the volume of water we need to add is lower than the total volume of the solution. With this simple procedure, you can prepare small-scale solutions for any nutrients you want to prepare. And with this preparation, you can figure out the exact amount of water you need to add by doing this weighing procedure that we carried out. And then you can scale to any scale you want. Doing this procedure, you can scale to 1,000,000 gallons if you want, because now you only need to weigh the salt that you're adding and you need to measure the volume of water you're adding. Both procedures can be carried out at very large scales very effectively. So through this video, we learned how we can scale up the preparation of hydroponic stock solutions without having to use accurate volumetric material. We figured out how to do this using small-scale preparations and then using this information, figuring out how much solvent we actually need, and then weighing in this case, but measuring the volume of the solvent for larger scales. I hope you enjoyed this video. Please make sure you leave any questions you have on the comments. I'll see you on the next video, and bye-bye.